I will introduce arrays in Python. We'll use the example of list, and I will show you how to handle a list, accessing items in a list and changing a list. Finally, we'll look at a problem with lists that we can solve by resorting to another type of array, which is the NumPy array. So lists are examples of arrays, and an array in general is a container for multiple items. So if you have more than one data point or more than one result, you might conveniently collect them in an array. For example, collect them in a list. So we're not dealing with recorded data points in this moment, but we can create our own list. So call it, for example, my list. And to create a list, you put it in square brackets, whatever items you want to have. And within the square brackets, you specify the items separated by comma. So if I just make a very simple list, which is 1, 2, 3, it contains 3 members, which are the integers 1, 2, and 3. If I just repeat the name here, then I will see the output below. And you can see also the output indicates squared brackets and of course the items as I put them in. So the access to items can be done by referring to the index of each of the items. Items are now referred to by the index. Index is zero-based. So slightly counterintuitive for beginners, but you can get used to it easily. You refer to the index in square brackets again, now following my list, and that means which item do you want to see? I want to see the first item, and in Python that is called 0. So if you do this, you will see the output, and it's the number 1. It's the first item in that list. And similarly, if we do my list 1, it will be the number 2, or if I just change it here and refer to item 2, it's the number 3. So this is what we have. If you refer to an item that doesn't exist, like item number 4, then you get an error. It's list index out of range. So you understand the error message. It's an index error. You have referred to an index which doesn't exist in the context of this list. So what we can also do is slicing, and that is referring to more than a member in a list. And we do this using the colon operator. So colon, if you just have a colon and nothing else there, you can see the output is just the whole list, so everything. And slicing then refers to taking part of the list by specifying either the beginning or the end of what you would like to have. I can do that. I can specify please start from the first item and do everything up to the end. And you can see, because it's a zero-based language, starting from index 1 is 2 and 3, because 3 is the last already. So everything up to the last item displayed. If you do the reverse and specify where you want to stop, you have to be slightly careful. So if you say you want everything up to item index 2, the index 2 stands for 3, right? What you see as a result is 1 and 2. So you don't see the last item. You have specified it, but you see everything up to except the last item. So it's inclusive on the left-hand side at the start. It's exclusive at the right-hand side at the end. If you know the value, like 1, 2, and 3 are the integers, if you know the value, you can also find the index. And I'll just show as an example how to find an index of a given value. So if the value 3 is what we are looking for, and asking the question, at what index do I find the number 3? Then you can do so by referring to a method which is following a dot, using a dot that follows the array that you're referring to, and you say index. Right? So you want to know the index of what? In round parentheses, you say which value, say 3. We want to know the index of number 3. So where is it? It's at index 2. If you assign that to a variable, give it a variable name, then of course you can also work with it, and you can specify that using the variable name later. So now we have found the number 3 in that array, and it's at index number 2. What if we refer to a value that is not in that list? So let's say we want to know the index of number 5. Then it gives you an error. It tells you the value error. You have referred to a value that doesn't exist. 5 is not in list. So this is slightly inconvenient in the sense if you think something is in the list and you refer to it in this way, then you will get an error. So it means your program will stop. There's also a way to check whether 5 is or not in the list, and you remember maybe it's illogical. So we can ask the question 5 in my list. And that's the question, is 5 in my list? And the answer is false, so the answer is it's not in your list. Or you can also ask the reverse, 5 not in my list? And then the answer is true. So you get an answer, yes or no, but it's not an error, as we see above, highlighted in pink. So it means your program will not interrupt, it will continue to run. Members, how many members are there in a list? Of course, you're not dealing with 3 numbers. Typically, you maybe deal with hundreds or thousands or even millions of numbers. So you need to know how many are there. Of course, you will always try to refer to existing members, but you need to know how many are there in the first place. So the way to check how many members there are in a list is to use len. Len, short for length. And if we just apply it to my list, and the answer is 3, this is the number of items in your list. So 1, 2, 3 items in my list, from which you know that you can refer to them by index 0, 1, 2. We can also change lists. So this is something that we cannot do with some types of arrays like string or tuple. We cannot really change them, but lists are changeable, and the technical term for this is they are mutable, or the noun is mutability. So the way to change a list, for example, use the method append, and you can append something to the list, say a new number, and just pick 55 as an example. And if we do this, show the code, if we do this, we have now a list that has 4 members, the last of which is 55 is the one that I just added. If I repeat that, if I highlight this cell again and do it again and again, I will have another 55 added at the end of the list. So I can add something. I can also remove things. For example, if I refer to my list, I can remove an item. For example, that 55, if I don't like it, I just remove it. And to see the output, 1, 2, 3, 55. I have removed the 55. Actually, I have removed the first appearance of that 55. And if I highlight and execute the code again, I have removed the second 55, now going back to the original list. Right. Read up more on specific details of how to change lists. But I can show you one last example, and that is if you want to replace a member in the list, you just refer to it by the index and assign it a new value. So how does this work? If I want to change the last item from 3 to 4, and I want to create a new list 1, 2, 4, what I would say, I would refer to that last item, say the last item in that list. Remember, it was called -1, and I just assign it a new value, say 4, and then if I see what the output is, and then the output is 1, 2, 4. So I've replaced the last item in the list with the value 4. And finally, I want to highlight a small problem that we have with lists, and why actually in data science we don't deal with lists, but we deal with a different type of array. So one of the problems that we have with list in Python is can be highlighted by just using the print function. So if I print my list and I also print my list times 2, what would you expect if I multiply my list containing 3 items times 2? So most of us would think of multiplication, and if I show you the result here, what you can see is the list is 1, 2, 4, and my list times 2 is 1, 2, 4, 1, 2, 4. So it has just doubled the list, which is nice. If you want to double it, you can also double the contents, but it's not typically what we want. So to have a better way of dealing with such a thing, like having the possibility to have each member in that list multiplied with that same value, which is the factor 2 in this case, we can use something called a NumPy array. So to create a NumPy array, we can, for example, convert the current list into a NumPy array. How do we do this? So first we have to learn to import from NumPy, which is the package to deal with NumPy arrays, from NumPy, and we say import. The function that we are going to use is asArray. So if I introduce that function asArray, and I've now activated it, I can use it. And what we do is we create a NumPy array, which I name my NumPy array for clarity, and I use that function asArray and apply it to my list. Right, and if I just say NumPy array so I can see the output, you can see my NumPy array is now an array, a NumPy array, which contains the same members as the list. So 3 items, first is 1, 2, and the last is 4, and so on. But if I now do what I did before with the list, let's do the printing again. Let's see my NumPy array, and let's see my NumPy array times 2. So, which is much nicer than before. Now we see the NumPy array is 1, 2, 4, and 2 times the NumPy array is 2, 4, 8, each member being multiplied with 2. And if you replace this single star here with a double star, so star star representing the instruction to take to the power of 2, so squaring, then you can see the output are the square numbers, in this case 1, 4, and 16. And it's of course a much nicer way to deal with it. And NumPy arrays are the preferred way of dealing with numbers in data science.